So in this video, we're going to be using the substitution method to solve simultaneous linear equations. Now, we use the method of substitution when at least one of the equations contains one variable in terms of the other. And what I mean by this is y equals something, or y equals something, or when x equals some equation. Okay. Now, I'll go through 3 examples so this will be clear. But what we're going to be doing is we're going to be substituting one equation to the other. Then what happens is we have one equation only in terms of x or potentially y. And then we can solve that and substitute it back into the original equation so we can find x or y. Now, it's hard to put it into words, so I'm going to show you the process. So remember, we need to identify which one we need to substitute in. So I'm going to label this as equation 1 and this as equation 2. So obviously equation 2 is y equals something. So y is equal to x plus 3. So what I'm going to do is I'm going to substitute equation 2 into equation 1. And what I mean by this is, so equation 2, y is equal to x plus 3. So I'm going to put x plus 3 where y was. So x plus 3 I'm going to substitute into y. So what I'm going to have now is 2x plus 3 lots of y, which is x plus 3, equals 19. Now, I've got an equation all in terms of x, which you guys should know how to solve. So I have 2x plus 3 times x, which is 3x, 3 times 3, which is 9, equals 19. Now, I can collect like terms. I can add 2x and 3x together, becomes 5x, plus 9 equals 19. And now I'm going to subtract 9 from both sides to get x by itself. So I've got 5x equals 10. And finally, I'm going to divide both sides by 5, because I've got 5 times x, I'm going to divide by 5. And I'll be left with x is equal to 2. So I've found one of my solutions. I found x equals 2. I'm not finished yet. I need to now substitute x equals 2 back into this equation, into equation 2. So I'm going to replace x with 2, because I know that x is equal to 2. So I'm going to have y equals x, which is 2, plus 3, which is equal to 5. So therefore y is equal to 5. So x equals 2 and y equals 5 makes both of these equations true and solved at the same time. So we've solved them simultaneously via the substitution method. So I'm going to do 2 more examples. So again, always start off by labeling your equations as 1 and 2. Work out which one is written in terms of 1. So you're looking for your x equals or your y equals. In this case, I don't have a y equals, but I have an x equals something. So x equals this. So I can replace x in this equation with this. I'm going to substitute equation 1 into equation 2 in this case. So I'm going to replace x with 3y take 5. So I'll have 3y plus 5 lots of x. And remember, x is just equal to 3y take 5. And that's all equal to 11. So then I can expand out again, and I'm going to have 3y plus 5 times 3y is 15y. 5 times minus 5 is negative 25, and that's equal to 11. So again, I can simplify. I can collect like terms. 3y and 15y becomes 18y. Take 25 equals 11. And now we need to do the opposite process. So take 25, we're going to add 25 to both sides. They cancel out, and we're left with 18y equals 36. 11 plus 25. And then 18 times y, so we need to do the opposite to get y by itself. We're going to divide both sides by 18. And then we'll be left with 36 divided by 18 is 2. So remember, we're not finished yet. We've got one solution. Now we need to substitute y equals 2 back into the first equation. So y is going to be replaced with 2. So we're going to sub y equals 2 back into equation 1. So now we're going to have x equals 3 times by y, which is 2, subtract 5. So 3 times 2 is 6, take 5. So therefore x is equal to 1. So now we've solved both these equations simultaneously. Y is equal to 2 and x is equal to 1. Now, the reason why I've done the third example, what do you notice about the third example? Well, they're both y equals something. Y equals something. So it doesn't matter what one we substitute into the other. So it doesn't matter. I'm just going to say substitute 1 into 2. So equation 1 is going to go into equation 2. So I'm going to replace this y with 3x plus 2. So I'll have 3x plus 2 equals 2x take 5. Now the only thing different about this one is that we now have x's on both sides of the equations. So we want to get the x's all on the left hand side. So to get rid of x from this side, we're going to subtract 2x from both sides. They'll cancel out. We'll be left with 3x, take 2x is 1x. And when we write 1x, we don't include the 1. So we'll have x plus 2 equals negative 5. And then we want to get x by itself, so we're going to do the opposite process and subtract 2 from both sides. And we'll be left with x equals negative 7. So that's one solution. We now need to sub x equals negative 7 back into either of these equations. It doesn't really matter to find y. I'll just do it into equation 1. So x is going to be replaced with negative 7. So we have y equals 3 times x. So 3 times negative 7, because x is negative 7, plus 2. 3 times negative 7 is negative 21, plus 2. So y is equal to negative 21 plus 2 is negative 19. So we've now solved these two equations simultaneously using the substitution method. Thanks.